Okay, number 9 is a little more straightforward. So 9 and 10, hopefully you can just kind of skip through if you missed a step. All right, cool. So once again, look at your original state. I know I want to start with the horizontal asymptote. So this one, the degree is actually bigger on the bottom. So bigger on bottom, that's going to be your BOBO. That means it's 0. So the horizontal asymptote is at y equals 0. And I'm going to go ahead and do that. So as I'm doing this, I'm just going ahead and sketching those pieces so that I don't leave something out. All right, at this point, my brain is saying like, oh, well, there's a line over the axis. If there's an asymptote over the axis, this graph is never going to cross the axis, then I automatically know this is going to have no x-intercepts. Okay, so I'm just like, cool, one less step I have to do. This is never going to cross the x-axis. Great. All right, so now I want to figure out all this other information, like what direction are my arms going? Are there any other asymptotes, vertical? Are there holes? So I need to factor this down to simplify it and see what's happening. So I'm going to rewrite this into factored form. So over here I have a GCF of x. So that's going to give me x times x minus 6. Now I have 2 x's in the denominator. So noticing that it's x squared in the denominator means there's going to be 2 discontinuities, okay? I don't know what they're going to be. They could be either vertical asymptote or holes. In this case, I have one at 0 and one at 6. So x cannot be 0 and x cannot be 6. Cool. What's the difference here? What happens at those points? Well, at 6, something very different happens than what happens at 0. So because I have this on the top and the bottom, that creates 0 over 0, which means that at x equals 6, I actually have a hole. So when x is 6, I have a hole on the graph. So when I go to try to put this 6, 1, 2, 3, 4, 5, 6, I don't know where to put my point. Just the problem like I had up here with this hole, right? So if I don't know where to put the point, I got to find the x and the y. So I'm going to say, okay, cool. What is the value of y when x is 6? So I'm going to go over to the whiteboard and I'm going to substitute in my new equation. So let me rewrite this in my new equation. So if the x minus 6 canceled, I'm just left with 1 over x. Great. That is just a basic rational function. That's your parent function. Should be much easier to graph than the last example. So I'm now going to say, all right, just to give myself some more space, I'm going to come over here. And I want to use the equation y equals 1 over x. But I'm using 6 because that's where the hole is, right? So I need to know what's the y value. Well, when I plug in a 6 for x, I just get 1 over 6. All right, so very close to 0. So 6 comma 1 over 6 is going to be the whole of this graph. So 6 comma 1 over 6. Your calculator may give you a decimal. You can write it in decimal form or in fraction form. So I know I have a hole at 6 and 1, 6. So let me go ahead and plot that. 1, 2, 3, 4, 5, 6. And then I'm just going to go up just a tiny bit. And there's a hole right there. Now I just need to figure out, is there any vertical asymptotes? Well, I still know x can't be 0. So that is going to be where the vertical asymptote takes place. Oops, I think I messed up my colors. Sorry. This should have been in blue. This is a hole. Too much going on. So 6 and 1, 6. That's the hole. Yeah, well, you get the point. That means the other one that's left over, let me not get my colors confused, is going to be your vertical asymptote. So this x equals 0 is your VA. So I'm just going to have right on the axis here a vertical asymptote. This looks much better. This looks much more of like what we've seen before. So at this point, I already know, well, there's no x-intercepts. I could find the y-intercept to see if that would help me. But it's not going to for this one because there is no y-intercept. So at this point, I would just need to kind of pick other points to make sure I know the shape. But I know because it's the parent function, it's just going to look exactly like the original rational function did. Just like this, and just make sure you have your hole. So the domain goes from negative infinity all the way, hits the axis here. And then here, just make sure you leave room for the hole. So it's going to be all real numbers, except x cannot be your 2 values over here, 0 and 6. And then range is all real numbers because this one does not have this space in it like this one did. It goes all the way up to the asymptote and then picks back up again. So it's all real numbers. Oops, I shouldn't have that. It's all real numbers except y cannot be 0 and where the hole is. So 0 and 1/6.